Hello, algorithmicians. In this video, I'm going to talk about Turing machines, giving you some examples that you can use for VCE algorithmics. This is an incrementing machine, so this will help us count up in binary. And to remind you what that looks like, binary counting goes like this. 100, 101, 110, 111, and so on. So we're going to start with our tape, and we are going to go from this number here. So we're expecting this to give us 110, and we start with our machine on the left-hand item, starting in state 0. This should really say state 1. Now, the first loop here tells us we're going to keep going keep moving to the right until we see a blank. So I'm going to put a blank here because we're going to need that. We could skip this. We don't have to show every single one of these states, but sometimes we need to count them. And so we'll do this 0, 1, 0, 1. Okay, so we've ended up in state 0 and we've gone to the right of the number we were trying to increment. And so now we're going to leave that being blank and we move back to the left. But now we are in state 1. So now that we're in state 1, we turn this 1 into a 0 and we stay in state 1. So 1, we're now here. That became a 0. And that is a 0, so we turn it into a 1. So that puts us then in the halting state. So we've turned that into a 1. That was still a 0. And we have stopped. And our 101 has turned into 110, which is what we wanted. Okay, let's see how this behaves on a slightly different case. So let's start on Q0 and we'll go 1, 1. I'll put a cross here to indicate I'll put a cross here as well. But we can think infinite blanks going in each direction. So that first step, we start here. We move to the right without changing anything until we get to a blank. So we should still be in Q0. 1, 1, and here we are, the blank state on the right. Q1 tells us if we are at a blank square, we move 1 to the left, so 1, 1. And then if we have a 1, we turn it into a 0 and move to the left. And we're still in state 1. We do the same thing again. Q1, putting us on this spare blank. And tells us that if we have a blank, we're going to turn that into a 1. Puts us in the halting state, so 1, 0, 0. And there's our final answer. We've gone from 1, 1 to 1, 0, 0, which, hey, that's what we wanted. Nice simple example, so feel free to try this again a few times just to see how it works. And I think it's quite easy with a few examples to get a feel for the logic behind this particular Turing machine. This one is a bit more involved, and the way this works, we're going to take two numbers, A and B, and we're going to compare them. The way we're going to write our numbers, we're going to write A as 1, 1, 1, and a 0 to separate them, and then B as 1, 1. So what we have here, A equals 3, B equals 2. So we're starting in state 0 on that first one. And let's work through this. Feel free to try it yourself first, or you can try it after I've done it with some different numbers. So we turn that 1 into an X, we move to the right, putting us in Q1. Now see we've got this loop above Q1, means we keep moving right until we hit 0. So you have to keep writing out every single line. We hit 0 here. We still move, but then that's going to put us in state 2. 1, 1, 0, 1, 1. So we're now in state 2, and we've moved to the right. We're going to turn that 1 into a cross. So we've got cross 1, 1, 0, cross, and we've moved to the left, putting us in state Q3. Q3, we can see we've got 0, so we need to move to the left and put us in state Q4. Q4, we have this loop which makes us move left once and then left again, putting us here. And we see there's a cross, so we're going to move to the right, and we're back in Q0. 1, 0, cross 1. Now, the fact we've gone back to our initial starting point, it's worth stopping and having a quick look. We've gone from, if you look at the top line here, we had 3 and 2. We've now gone 2 and 1. So that might give you an indication as to how the sort of logic behind this particular Turing machine. So we start by turning the 1 into a cross and moving to the right, transitioning into state 1. We're in 1, we move to the right again and we stay in 1. We've now got 0, so we move to the right again, but we go to state 2. Cross 1, 0, cross. When we're in state 2, if there's a cross, we move to the right again. And now we've got that 1, we're going to turn the 1 into a cross, move to the left, and transition to state 3. In state 3, we move to the left because we see a cross. Now we've got 0, we move to the left, but transition to state 4. From state 4, if we see a 1, we move to the left, then we see a cross, so that puts us back in state 0. And we've moved 1 to the right, so we're back here. So now we're comparing 1 with nothing. So we can see the first number should be greater than the second number. Let's see how this turns out. We're in state 0, we see a 1, so we turn that into a cross, and we move to the right, putting us in state 1. If we see a 0, we move to the right again, putting us in Q2. We see a cross, we move to the right. We see another cross, we move to the right. And here we are, we've hit a blank, so we end up in this halting state, which is that A is greater than B. So once again, try this machine out yourselves. Again, I think this is nice because the logic, it's not as obvious as the last one we did, but it's still fairly clear. Now, let's look at some exam questions. Have a quick look through this question yourself, and you may even just want to give it a crack based on the technique we looked at before. Now, I'm going to rewrite this tape. We're told we're starting in state 1. We've got 0, 1, blank, 1, 1, 1, blank 0, halting 0, 1, blank 1, 1, 1, blank 0, halting. Good to double check that. And we're starting on that first 0. So if we see a 0, we move once to the right and we stay in Q1. We see a 1, we turn it to a blank, and we move to the left. Still in Q1. Again, we see a 0, so we move to the right. And now we see a blank. We're going to transition into state 2. And we're going to change the blank for a 1 and move to the right. So the blank has turned into a 1. We've moved to the right. Everything else is the same. How many steps have we done so far? 1, 2, 3, 4. The first line isn't a step. Now we're in Q2. We see blank. Blank stays as blank, but we've moved to the left. And that answers our question. After the fifth step, we are in state Q2 and 1 position to the right. And now we have to work through this whole thing until we get to the halting state. So in state Q2, if we see a 1, we turn it into a blank and we move to Q3. So Q3 is now going to be 1, sorry, we've got 0. That 1 has turned into a blank, and then we had blank 1, 1, 1, blank O, H, and we've moved to the right, so from that one to here, so in Q3. If we're in Q3, we see a blank, we turn it into a 0. We move to the right, and we go back to Q2. In Q2, if we see a 1, we make it blank. We move to the right, and we transition to Q3. So 0, B, 0, 1, B, O, H. And now, because we're not worried about the number of states, I'm going to just follow this loop. So in Q3, if I see a 1, I leave it, and I go to the right. I do that again. In Q3, I see a blank. I change that to a 0, and I move to the right. 1, 1, 0. And that has put me in state Q2. I'm in Q2, if I see a 0, I move to the right, putting me on that halting thing on the tape, and also puts me in a halting state according to that diagram. B, O, B, O. So that's put me in the halting state. And this is our final tape representation. O, B, as in O blank, 1, 1, O, O. And the position is on the H, and that was one of the multiple choice options, which I took out just to make space. Okay. This next question is trying to ask us to think backwards, I guess you might say. We're given a tape, and we're not told where the head starts, but we're told where it finishes, and we're given the result. So what you can see is the tape has remained pretty much the same, but the initial 0 has turned into a 1. And I had to go at this by trying to work backwards, but it ended up with an ambiguous situation. So I think it's actually better if we do this one by trial and error. And hopefully I'm going to be able to do this well enough by scribbling over the tapes here. So we're starting at Q0 down the end here. It's blank, so we move to the right and we're in Q1. That's blank, so I overwrite that with a 1 and I move to the left and I'm in Q2. That's blank, so I leave it as blank and I halt. And you can see that's nothing like the final answer, so it's not A. In fact, that didn't take too long, suggests it shouldn't take too long for the others. So B, we'll start in state 0. And if we look at these two loops on state 0, it says essentially stay in 0, keep going all the way back until you hit a blank. So we can skip a bunch of steps there. When we get to the blank, we leave it blank. We move to the right and we change into state Q1. If we see a 0, we turn that into a 1. We move to the right and we transition into Q2. The Q2, whenever we see 0s or 1s, we move to the left until we see a blank, which puts us in that halting state. And that is, in fact, what we were after. Just forgot that after that before we move to the halting state, we do move to the right, so we end up here. Okay, so that's where we can say that B is definitely the answer. Now let's talk through how we might reverse engineer this. So if we start with that final tape, and we know that we were on here, that was our halting state. So we must have moved to the right, so we must have been here in state Q2. Now these loops here say that we keep moving to the left if we see 0s. So we know then that we're going to end up down at this end of the tape somewhere. And we've got to work out which of these incoming instructions could have happened. Did we turn a 0 into a 1 and then move to the right? Or did we turn a blank into a 1 and move to the left? And it's not entirely clear because we don't know how far down this tape we ended up. So just looking at this, we can't tell if we ended up here, let's say, and that was blank, and we turned it into a 1 and then moved back here. So I did spend a bit of time trying to figure that out. I don't think you can reverse engineer it, but if I'm wrong, let me know. Question 19, which relates to the same question. We've started here, so we're going to count the steps again. We're going to do this one fairly carefully. In fact, I'll use this tape as my starting state tape. So starting on Q0, step 1, we've moved to the left, staying in state 0, 1, 0, 0. It's a bit of a pain to keep rewriting this, but it's safer. Get rid of some of these. We're at 0, so we stay in 0, we stay in Q0, and we're now on that blank. 1, 0, 0, 1, 0, 1. We're at blank, so we move right into state Q1. That's a 0, 1, 0. In Q1, if we see a 0, we turn it into a 1 and we move to the right and transition into Q2. 0, 0, 1, 0, 1. With Q2, we keep moving to the left. So we'll do this step by step, won't we? So as the next step, still in Q2, 1, 1, 0, 0, 1, 0, 1. Then we hit a blank. And then this puts us in that halting state. So how many steps? We've got 1, 2, 3, 4, 5, plus the halting state is 6. Count, I should have counted this one here as well, because the tape was the first one. We started with the tape, then 1, 2, 3, 4, 5, 6, and I haven't drawn it in, I've run out of space. The 7th step is moving from Q2 to the halting state. So the answer was B, which is 7. Okay. Now have a go at writing down the key bits here, and I write down some keywords and then try and form that into a sentence. So what do we know about the tape in the Turing machine? It's the tape specifically. We don't want to discuss other stuff. So it stores data. It's got a defined alphabet. It's read and written to. And the Turing machine moves left and right over the tape. Okay, so it's quite possible the tape moves in relation to the Turing machine, but of course that has the same idea. Reference the idea that it provides you with input and output. Okay. Finally, question 20. Which of these is not necessarily a characteristic of the Turing machine? I think we can do this by a process of elimination. I mean, no, the tape has to be divided into cells. It's not like some continuous thing, so that's true, so we eliminate it. Table of instructions must be finite. I mean, everything we've done in algorithms suggests that, and we've seen a whole bunch of finite instruction tables. Somewhere or other, we have to store the current state of the machine. And the thing we know is that we haven't seen this happen, that the tape head can jump to an arbitrary cell on the tape. Machine which moves multiple spaces, but the tape doesn't have a defined beginning and end, so it doesn't really make sense to say jump to an arbitrary cell on the tape unless there's been some programming to work out where a particular cell is. Like you could have programming which takes you the third to the right of the blank cell on the left. Let's say the first blank cell we find on the left. So our answer here is A.